So we have been talking about habitat all morning, and now we get to move into what the habitat is for, which is for the birds and other animals. So I'm going to be talking about results from the density management study, but with reference to other thinning studies. And first of all, I would like to acknowledge Jennifer Weichel and Dan Edge, who initiated this study back in the pre-treatment days, and they designed the first bird surveys and collected pre-treatment and early post-treatment data, which I've incorporated into this presentation. So the primary objective of the density management study and of other thinning studies being carried out in the region is to evaluate the effects of alternative density management treatments in young stands on the development of late successional forest habitat attributes. And of course, the corollary to that is to evaluate the effects of those treatments on the species that use that late cereal forest habitat. And so, what is that habitat? I'm going to talk just a little bit about key features of bird habitat in late cereal forests. Actually, my colleagues have already done a pretty good job of talking about some of these features. But what's important from a bird's eye view in particular, it's not so much the age of a stand, but these structural features, things like large trees and large snags and vertical diversity, which again from a bird's perspective is comprised of a conifer overstory and then importantly deciduous trees in the mid-story and shrubs in the understory. So I always like to emphasize that vertical diversity from a wildlife perspective isn't so much just layers of conifer from the overstory down to the saplings in the understory, but that deciduous tree and hardwood component is really important, and it's what contributes the functional diversity. And as I said, these things aren't so much related to forest age, although they do, of course, you tend to get more development as the stand ages. But these are all things that are affected by thinning. And so the expected effects of thinning on these habitat features are both, they have long-term side and the short-term effects. And over the long term, we expect that the development of late cereal habitat will be accelerated through thinning, and that we can maintain structural diversity in stands and eventually create bigger snags. But the effects in the short term are often contrary to those long-term effects. So in the short term, we have a reduction in canopy, and even before understory development, which I've listed here, if you remember from Klaus's talk, you get suppression of the understory just from the mechanical treatments of thinning, running over shrubs. And so very early on post-thinning, the shrub layer can be reduced, and then eventually it recovers and you get understory development. And in the short term, if you remember from Eric's talk, there's fewer snags. Mostly we're talking about the small diameter snags, but still fewer snags in thin stands. So we haven't been at these experimental thinning studies long enough to address the long-term questions yet, which are the real questions of interest. Can we create old-growth habitat from young stands? So, but we can address some short-term questions, and those are what I'm going to talk about today. And the main thing being, for my talk, what is the effect of different patterns and intensities of thinning on songbirds? And this is in the early stages post-thinning. And the response variables I'm going to look at are community composition, so the species that are present, and the density and abundance of those species, and with particular attention to what happens to the species that are associated with late cirral habitat. And I wanted to mention that for songbirds, there aren't really very many species that are very strongly associated with late cirral habitat, although there are several that reach their highest abundance in older stands. And that will be important later on when I talk about the results. So the density management study is one of several experimental thinning studies here in the region, but it does have some differences from other studies. And I put unique here, that could be in quotes because these are actually some challenges presented for somebody who wants to study birds in the density management study. And of course, the complex treatments that were installed are a key feature of the density management study. There's gaps, leaf islands, buffers, and variable density. And you can see it creates quite a busy patchwork, especially from a bird's perspective. So many of the territorial songbirds that we studied can easily move around and cover the territory that would be at least as big, or would encompass maybe a couple of gaps. And I don't think I have a laser here. But, oh, there. So here's a gap in the variable density treatment, which is in orange. And a typical songbird territory could, cover an area around a few gaps and overlap a couple of treatments. So that presents a challenge in really deciphering what bird response to a treatment is, because unlike the lichens that sit in hot spots very nicely and you can say exactly where they are, the birds move around. And so from a bird's perspective, this whole set of treatments might look like a single treatment, just a very variable and complex treatment. And that also is affected by the fact that the treatments are adjacent to one another. And birds don't acknowledge those boundaries, and so they easily cross over from one treatment to the next, and whatever treatment is adjacent is going to influence what birds you observe. And then another unique aspect of the density management study is the fact that some of the stands are or were rethinned. And so that presents an interesting opportunity to learn what happens from rethinning, but it really complicates sampling. And this is the sampling timeline for the songbirds, and I want to spend a little bit of time on this because it shows that we had, I divided the study into 3 or 4 phases. And I sampled 4 stands, or 4 blocks. Those are the four blocks that I sampled. And then in 1998, we had the pre-treatment sampling. So the A represents pre-treatment. And the thinning on the first thinning on these stands didn't all happen in the same year. And so 1999 was another pre-treatment sampling for 2 of the sites, Green Peak and 10 High. But it was the first post-treatment sampling for Bottom Line and O.M. Hubbard. So B represents the second, or the first post-thinning. And then there was a gap of time between 2000, when Green Peak and 10 High had their post-treatment sampling, and the next post-treatment sampling was done in 2008 and 2009, which was also the pre-rethin sampling period. And then only 2 sites have been sampled since the rethin, and that's represented by the D phase at bottom line in O.M. Hubbard. So a rather complex sampling scheme for the birds, and I'll try to make sense of it. I should just mention that we sampled bird abundance or density. So we went out there and counted the birds we observed. We don't have any information on reproduction or what they were doing in these stands, only that they were there. So I'm going to talk about the preliminary results, and I do have to emphasize that these are preliminary, but I have some confidence in them because they're very similar to results that I've gotten from the young stand thinning and diversity study. So this is the first of several graphs I will show you like this. I'll spend a little bit of time on it. And it shows along the x-axis the 4 phases I just talked about. So A is pre-treatment, B is early post-treatment, C is later post-treatment, and D is after the rethin. And on the y-axis, in this case, we have species richness, but the great thing about the density management study and the young stand thinning and diversity study is that we have controls, spatial controls, and so I can use those to estimate the response of birds, the difference between the abundance or density in the treatment and the control in the same year, and that way I can dampen out the effects of interannual variation. So what we're looking at is the difference between the treatments and controls. So the 0 line is where there is no difference between treatment and control. And if it's above 0, then it's a positive effect of thinning. In this case, more species in the thin stands than the control. And if it's below the line, then it's negative. And the error bars represent 95% confidence intervals. So this shows that in the pre-treatment years, you can see that the 3 treatments, high density, medium density, and variable density, were not different than control, which is good because they hadn't been thinned yet. So that's right where we want them. And then you can see that in the post-treatment years, the medium density and variable density, the species richness is increasing in those treatments above what was in the control. So like as for other studies, this is getting to be a familiar pattern for bird response to thinning, is that species richness increases. And this is a similar chart, but this is for total density of all birds combined. And you can see again that there's a positive effect of thinning, and it's most accentuated in the more intensive stands, or treatments, the medium density and the variable density. And that the high density never got that different from the controls yet. And this also is a similar pattern to what we're seeing in other studies. So there's more species of birds in the thin stands immediately after thinning, and there's more total number of birds. So it sounds like thinning is a good thing for birds, but not all species were affected the same way, of course. And I have at least a dozen species that we have been able to analyze and look at their response to thinning. Of course, I'm not going to go through them all. That would be a little much, but I just want to highlight some of them and show examples. And this one is for McGilvery's warbler, And I'm comparing the results for this species in the density management study to what we observed in the young stand thinning and diversity study. And you can see it was a really similar pattern where these birds did not occur. This is a early cereal associate, strongly associated with shrubs. They were not, they didn't occur before treatment in these, they didn't use the habitat. They colonized afterwards, and it seems like the more disturbance, the better these species like it. So again, I've seen really similar responses between these two studies for all the species. There were no surprises, in fact, no differences between the studies in terms of the general response of each species, which is it's good. It shows that we're getting consistent results, so we're figuring out what's going on with these guys. This is the Swainson's thrush, another shrub-associated species, and I put this in because it's interesting to see that immediately after thinning, in the B phase there, it actually decreased in the variable density to where it was lower density in those heavily treated stands than in the controls. And that's probably related to what happened to the shrubs immediately after thinning, what Klaus was talking about. The shrubs were suppressed. And then as the shrubs recover, this species also seems to recover. And this species likes to eat fruit. And so John Tapner's results showing that the fruit production was higher in the thin stands probably influences this species. There were some species that responded negatively. This is the Pacific slope flycatcher, and you can see that for after thinning, for all the 3 phases after the pre-treatment period, the density decreased relative to controls, and the thinning, whether it was high density, medium density, variable, didn't really matter very much. It just had a negative response to thinning. And the Pacific slope flycatcher is one of those species associated with late cereal conditions. It's not, it occurs ubiquitously everywhere, but it reaches the highest abundance in late cereal. And that's true with the winter wren and brown creeper, also had negative responses to thinning, also are considered late cereal associates, but are fairly common species. And so that suggests that even if they're responding negatively to thinning, they're still around. So we didn't lose them out of the stands, and there's a possibility that as the stands develop, and if they do indeed develop late cereal structure, these species could recover. But it's a different story for the varied thrush, which was present during the pre-treatment and early post-treatment, but then we did not observe it in these stands again. And this species, the varied thrush, which is shown in the picture there, endemic to the Pacific Northwest and has been experiencing population declines throughout the region. So that's one species we might want to be concerned about. And cavity nesting birds are also old forest associates, many of them, because of the large amounts of dead wood in old forests. And they're really important as primary, the woodpeckers are important as primary excavators. They excavate cavities that other secondary cavity nesters can use. And there's a lot of cavity nesting species that these woodpeckers provide habitat for. So they're really important, and managers are concerned about them, so they're of interest. We want to know what happens to them when we thin. They're not well sampled in the density management study or really in any of our thinning studies because they have larger territories than the size of our units. But I did pool several species together and combine their density so that I could take a look at it. So this graph represents the combined density of the 4 major primary excavators. That would be hairy woodpecker, pileated woodpecker, northern flicker, and red-breasted sapsucker. And this shows that they did have a little increase in density above the controls immediately after the first thinning, which seemed to fade away by the second post-thinning phase. And then when we came in and disturbed the stands again in the rethin phase, their abundance shot up, or their density shot up again, mostly in the variable density and medium density. And so this just shows that these woodpeckers do have most of them have a positive response to thinning, which is kind of mysterious since the snag density decreases, but there's something about the disturbance that attracts them, and but it doesn't last very long. We'll expect that effect that we see in phase D there to fade again, but it'll be interesting to see how long it takes to fade. So this is my summary of what I've discussed. The short-term response of birds to thinning, and this is consistent across thinning studies, an overall increase in species richness in response to thinning, mostly as a result of early cereal species coming in and colonizing, and we don't see the loss or species that are absent from stands afterwards, except in a few cases like the varied thrush. So species richness increases. We see increases in species associated with open canopy conditions, including primary excavators, the woodpeckers. And we see decreases in species associated with dense closed conifer canopy, and several of those are species that we think of as associated with late cereal forest stages. And then another thing that I forgot to mention earlier, to point out to you that there is minimal differentiation among the thinning treatments. So the biggest differences we saw were between thin treatments and controls. And Klaus noted that for the effects on the understory and overstory as well, I believe, that not so much different among the thinning treatments yet, although we expect that to develop as time goes on, that perhaps these treatments will differentiate. So since this study was intended to address long-term questions, we're going to need to continue on monitoring and surveying the birds to address these questions and to find out the answers to things like how soon will the thin stand support an old forest assemblage? Because right now we've mostly seen that the birds that are characteristic of old forest have decreased. And so we'll be interested to see when the direction of their response to thinning changes over time. And then related to that, which thinning strategy would be the first to develop old forest structure and therefore support these old forest species. And we have, as I mentioned, the methods we use tells us what birds are out there using the stands, but it doesn't tell us why they're there or why they're negatively affected by thinning. And in order to get at those questions, we need to understand the mechanisms underlying the responses. And there's several areas that would be good to investigate, including the landscape scale effects. When we first started this study, there was only a little bit of thinned area out there. And now, a decade or more later, there's a lot of thinning that's been going on in these stands. And so the landscape surrounding the stands has changed, which is going to influence the species. And then, of course, we don't know what they're eating and how they're interacting with other species. And that's it. have time for questions.
Short question?
In most cases, you demonstrated that there wasn't a lot of differences among the thinning treatments in terms of response, but in a couple of cases, it indicated that the variable density treatment was showing somewhat different responses than the other two.
Yes.
When you think about that treatment, it has two elements that I can think of. It has a component that's a low density component that's lower than either the moderate density or the high density treatments. Then it also has, amongst those areas, it has smaller areas in each of the three densities as applied to those variable density treatments. Is there anything in that that you can kind of might stimulate some hypotheses about why that treatment's behaving differently?
Yeah, it did. It was the most heterogeneous for sure. So it did provide a lot of potential for niches, and then for this, like for the species that responded positively, it had the gaps in there, of course, and the it was just a really complex treatment. But as I said, the scale of the treatment was it was small relative to the bird territory, so there would have been a lot of complexity within a bird territory. So yeah, that's something worth thinking about. I wish I could get at that question better with these data. I'm not sure that I can, but it's good to think about. Okay.
Well, thank you, Joan.